That's like better than my eyesight.
It's better.
It is. Like if you look at how the pen.
Hey audience, this is Lily talking. This is very entertaining. You're seeing this in Super HD. Okay, so we're supposed to solve this differential equation by separation of variables. So that means we have to get the dependent variable over here, so the y over here. So I've got cosine x. We could make that e to the y times e to the sine x. You can separate those two. That's a little tricky. And so now we're going to move the y stuff over. We can either multiply or divide it. We're going to multiply or divide. So I have, I'll make it e to the negative y on this side. And then we integrate both sides with respect to x. So it's going to be dy dx dx. So those are gone. So left side is integral of e to the negative y equals integral of cosine x e to the sine x dx. So we can find the antiderivative, which is negative e to the negative y equals, this is a little u substitution going on right here. So u is sine x. So dx equals du over cosine x. So just rewriting this in terms of u, it would be cosine x e to the u times du over cosine x. Antiderivative is just e to the u. So it's e to the sine x. So both sides have a plus c. But if you have this c and then you move it over to this c, you just end up with 1c. So now we just have to solve for y. And we're done.
Both sides have a plus c and then you subtract the c.
So they're different c's. So if think of it as c1 and c2. c2 minus c1 is just c.
Okay.
Good question. So e to the negative y equals negative e to the sine x. C times negative 1 is still plus c. Natural log. So negative y equals a natural log of everything over here. So it's the negative natural log of negative e to the sine x plus c. Good question.